Okay, and we are going to go to page 14. Page 14. Phones away in your bag. Page 14. Haley, page 14. Elias, page 14. Everyone whose book is closed, page 14.
Do you have an extra pencil?
I have an extra pencil.
Thank you.
Okay, can I have your attention, please? In 5, 4, 3, 2, 1. Excellent, thank you. Conductivity of substances. Substances. Can we wait till later? Because we've had lots of time to do other things. Yes? Substances can conduct electricity. So they can. If there are two things. One, they have to contain charged particles. The second thing is if they are going to conduct electricity, those charged particles have to be able to move. So I would like you to brainstorm with your partners. What are some charged particles? What are some charged particles? If you are not talking about charged particles, then your mouth is shut. Do we understand each other? What are some charged particles? Ions, beautiful. Ions are charged. What else? What are some other charged particles? Yes. Electrons, yes. Yes, protons. Those are the charged particles that we have learned about so far. I'm sure there's others, but really those are the only ones that we deal with in chemistry. Okay? Ions, electrons, and protons. Can ions move? All the time, sometimes, none of the time. So, can ions move all the time? Some of the time? None of the time. Now, when I say chat with your partner about this, that means chat about this, not about other random things. Understood? There will be time for random chat later. Go. Can ions move all the time, some of the time, none of the time? Okay, so you guys are going to get to vote on this. Shh. And you get to vote with either the letter A, which if you've forgotten from before Christmas, you put your fingers on your palm like this and your thumb beside your fist. That's an A. Okay, so everyone just practice an A. A. B, you put your palm open and you put your thumb on your palm. That's a B. So let's do A again. A. B. B, your thumb is on your palm. A. B. Go back to A. Go back to B. Go back to A. Go back to B. And then C is just like this. D. It's with all your fingers together and your pointer finger up. That's a D. Okay? So A, B, C, D. But we don't need D today. We'll do D another day when we have another choice. So you get to vote either A all the time. Excuse me. You get to vote A all the time, B some of the time, or C none of the time. 5, 4, 3, 2, vote. Okay, I got some C's. I got some B's. All right, let's see what we got. If I have a solid, do you remember that blue crystal from yesterday? Trying to figure out where I put the blue crystal. Do you remember the blue crystal from yesterday? Yeah. That was an ionic crystal lattice. Oh. Just like this. Are these ions able to move? No. No. So in a solid, the ions cannot move. No. So, if, you can go later, okay? If they cannot move, can this conduct electricity? No. So it has ions, but they cannot move. So it meets criteria 1. It has charged particles, but they cannot move. So it has charged particles. Check. But number 2, the ions cannot move. No. And if that's the case, if either of these are an X, that means it cannot conduct electricity. Do you guys remember what happened when we put the 2 wires onto the blue crystal yesterday? Nothing. There was no light. Okay? So if we look here, right? Here's our solid ionic crystal. there is no light. And why is that? Hi, come sit right here, please. So we have a solid ionic crystal. Yes? Okay. No light. Did we have ions that could move yesterday? What did we have to do with our ionic compound to make it conduct electricity? We had to put it into water and dissolve it. Okay? So if we take an ionic compound, actually we're going to skip to the next page just for a moment, we'll come back. So we're now on page 15. Do you remember the word for dissolved in water?
Aqueous.
Aqueous means dissolved in water. Now, if it's dissolved in water, we have the ions. But instead of all being stuck together, here's our water. There's a positive over here, a positive over here, a negative over here, a negative over here. Can those particles float around and move? Yes. So ionic compounds in solution can move. You can see these ions can move. The ions float freely in the water. So the ions can move. And what's going to happen is that we are going to have a positive terminal on our battery. Let's just make this one the positive one. We're going to have a negative terminal on our battery. I don't know why this one has both on the top. Maybe it's a 9-volt. You know how 9-volts have both on the top? Those little square ones? Okay. I don't know why this one looks like this. Anywho, what that means is that this little stick here, this is going to be a metal stick. Just like those wires that we put into the solution yesterday. And this one is going to be positive because it was attached to the positive terminal of the battery. What charge is this metal stick going to be? It's going to be negative because it's attached to the negative terminal of the battery. I don't know what's with these weird little lines that my pen is making. It's very irritating, but that's okay. We can make it work. There we go. Okay. Now, if I had a negative over here and a positive over here, what if I had a positive ion right here? Which direction would it go? Would it go to the left or would it go to the right? Have a discussion about that. I hear some people saying left and some people saying right. Which direction is that positive ion going to float?
All right, my God.
It's going to go to the left because it is attracted to negative. What if we had a negative ion? It's going to go to the right because it is attracted to positive. So we have our cations going one way, we have our anions going the other way. But in order for electricity to flow, we need a complete circle, right? What's the other part of the circle? We've got the solution. What else is carrying charges in this? The battery, yes. What else? And the light. We got the battery. Why is this not working? Because I don't have my glove on, that's why. So we have the battery. We have a light, and it's on. What else are we missing from here? We've got the battery, we've got the light, we've got the salt solution, we have the metal sticks, and there's one part of this circuit that you haven't talked about yet. The wires. And while you do that, you can fill up Elias's water bottle for him. Okay. Now, what is flowing in, what charged particles are flowing in the wire? Yes. Nope. Kai's out right now. What charged particles flow in the wire? Is it positives? What's the wire made of? The wire is made of metal. What kind of particles are in metal? This is thinking back to yesterday and yesterday's homework. What kind of particles are in a metal? Feel free to look back on page 6. Go back to page 6. We got 2 things in the metal. What are the 2 things we have in the metal? We have electrons and what else do we have? We have cations. Positive ions, cations. Which of those 2 which of those two, the electrons and the cations, which of those two move? Is it A, electrons, or is it B, the cations? Is it A, electrons, or B, cations? It's A. It's the electrons. The cations are stuck in position and the electrons move. So if you have a wire, we have electrons moving. So let's now go back to page 15. What kind of particles are in a metal? Those are electrons and cations. Which ones move? And that would be the electrons. So what kinds of things might I ask you on a quiz or a test around this? I could say, in an ionic solution, what are the charged particles that move? Should I write this down somewhere? Yes, let's do that. Okay. Questions I could ask. In an ionic solution, what are the charged particles that move? Think of another question I could ask along those same lines. See if you can come up with another question. Do you have an answer? Okay, then be chatting about it. What else could we ask about? In a something, what are the charged particles that could move? What could I be asking about? So we could start by saying, in an ionic solution, what are the charged particles that move? In what other kind of substance have we looked at? Sorry? Metallic solution? Ooh, metallic solution, not quite, but you're on the right track. They don't move in covalent ones. Metals don't actually form solutions, but we could just ask about ions? Is that what you said? Yeah? Oh, no, because there's no such thing as ions on their own. What have we talked about yesterday? What did we talk about? The delocalized electrons, which are in what? Metals. In a metal, what are the charged particles that can move? Yeah? I could also ask, what are the charged particles in A, ionic compounds, and B, metals. So what are the charged particles in ionic compounds? It's not hard. Ions, okay? Ions. What are the charged particles in metals? Electrons and... Is there anything else in a metal? Cations. So now we know what those charged particles are. Those are what the charged particles are. In an ionic solution, what are the charged particles that can move? In an ionic solution. Again, it's not difficult. It's an ionic solution. Ions. In a metal, what are the charged particles that can move? Electrons. Okay? So those are some questions that I could ask, just to give you an idea. I'll keep adding on to this list. If anyone would like a printout of this, just raise your hand now and I'll make printouts before the end of class. I will make a class set. Okay, excellent. All right. Let us grab this, control print screen, grab this, da-da-da-da. Let's toss it in here. You may, yes. Would you like a mug? You can go to the water fountain. Okay. And I'm just going to press print on this. File, print, and I want 15. There we go.
What do you want? Yeah. I love feeling yeah, but it is, you know, I didn't learn how to do everyone.
Now, this would be your opportunity to chit-chat about things that you want to chit-chat about. Just give me a minute and we'll get back to my stuff later. Okay? So take a moment, have a little chit-chat.
Yeah. Why don't you ask me? I saw the fire.
You had a question, Lucas? No, never mind. I'm hearing things.
You wouldn't say. Okay, you know. That's sweet. Good boy. What's the longest? Good boy. And try.
Okay, folks, we're going back to page 14. 1-4. Back to page 14. And one of these who wanted one.
What? Oh my God.
You have one? Okay. Back to page 14. There you go. Okay, your attention in 5, 4, 3, 2, 1. Back on page 14. Back on page 14, we are looking at liquid ionic compounds. Liquid. Not aqueous, liquid. Tell your partner what is the difference between aqueous and liquid.
Salt and water.
Page 14. We did, but then we came back to page 14. We've done a little bit on 15. So what is the difference between aqueous and liquid? Aqueous is dissolved in water. If we want to make something liquid, do we dissolve it? What do we have to do to make a solid into a liquid? We have to melt it. Dylan, what do we have to do to turn a solid into a liquid? We got to melt it. Good. Nice work. Okay. Paying attention and talking at the same time. I can't complain. Well, I can complain, but I can't complain as much about that. All right. So if you look at a melted solid, if we have a negative plate over here, that would be attached to the negative terminal of the battery. What? How do we draw a negative terminal of the battery? Just using like a little drawing. Do we draw a big line or a short line? The negative terminal is the short line. How do we draw the positive terminal of the battery? Long line. So that's negative, that's positive. Up here we have positive. If this is a molten salt, then just like water, the water molecules can move past one another. Those ions can move past one another. It's as though I took this thing and I sawed all of these little bonds, and now everything can just move. Which direction will the positive ions move? Will they move towards negative, or will they move towards positive? They're going to move towards the negative. So the red ones move this way. Which way do the negative ones move? They would move towards the positive. Okay? So that's conducting charge. Tell your partner, what are these positive things? This is a what? That is a ion. What kind of ion? Cation. And what kind of ion is this? That's an anion. Good. And that is a liquid ionic compound. Okay? And look, if you do that, you get a glowing light bulb. Okay? So aqueous ionic can conduct electricity. Liquid ionic can conduct electricity. Solid ionic, can solid ionic conduct electricity? I don't know. Think about that. Can solid ionic conduct electricity?
Oh, no.
No. I'm not going to get fancy. I'm just going to say no conduct. No conduct. Okay. Now we're on page 15, down at the bottom. Here we have a little video. Shall we watch the little video? Let's watch the little video. Why not? Oh, because I don't have it linked. Never mind. We'll do that later. Metals, solid. Can they conduct?
Yeah.
Conduct, yes. Metals, solid. Can they conduct? Yes. Do they contain charged particles?
Yeah.
Yes. Do they have charged particles that can move?
Yeah.
Yes. And if you've forgotten, what do we call this blob with all the electrons in it? Nope. That's a sea of electrons. That's a sea of mobile electrons. What's floating in the sea? Actually, I shouldn't say floating because they're stuck in place. What's stuck in place in the sea? Yeah. Metal cations. Okay, good stuff. Look at the direction that the arrows move when we don't have any electric field. So this is like a copper wire with no battery attached. Copper wire. Not attached to a battery. Which way do the electrons move?
Everywhere.
Everywhere. The electrons move everywhere. Every which way. Okay, they can go up, they can go sideways, they can go diagonal, they can go whichever way they want to. Okay, they're just randomly moving. And they're moving all the time. Okay, if I got this wire here, are the electrons in it still or are they moving? They're moving just randomly, any old direction. Okay? But what if we attached a battery? This is going to be our negative, this is going to be our positive. All of a sudden, the electrons say, over here, I see negatives. What do electrons do when they see negative? Do they run towards or do they run away? Electrons run away from the negative. And they run towards the positive. Okay. Oh my gosh, what have we got here? Metals, liquid. Do they can change particles, charged particles? Yes. Do they can those particles move? Yes. It would look the same as a liquid metal. It's just it would be much less exciting. Molecular / covalent. Do molecular compounds contain charged particles? Let's take a look. Here's a covalent compound. Whoops, covalent compound. What kind of particles in it have charges? We have electrons and we have protons. So do we have charges?
Yeah.
Yes, charged particles. But our second question, so that's question number 1. What is our second question we have to ask? First we ask, are there charged particles? Second we ask, can they move? Can they move? Can I move these electrons to say over here? Can they move over there? Would that be okay? No. In covalent compounds, the electrons are locked in place. Then we have like a little black diamond thing here that you don't need to know if you're not doing black diamond. Yes, yes. And finally, this is our last one, and then we're done. This is on page 18. So this is aqueous ionic. That's NaCl. This is aqueous covalent. Sugar. C6H12O6. NaCl. Do we have, over on our left, do we have charged particles? Yes. Can they move? Yes. Over on the right, do we have charged particles? Does C6H12O6 have a charge? No. So is there any point in asking, can they move?
No.
No. So this can conduct, this will conduct. Whoop, I can't spell. Conduct. And this one, no conduct. Okay? And that's it. If you're interested in the covalent network solids. You can read about those on your own time. Homework. Page 22. Just page 22.
Take these out. You don't watch this like that. I need a pair for. Thank you. I think so. Well, here's. I need a pair like plugged it for me. Are they refining where?
Yeah, great. Oh, yeah, perfect. Just, happy to bring it over. I just got the most happy.